Okay, we can start? Okay, so I'm Didier Stevens. I gave a workshop here last year about malicious PDF documents and how to use my tools to analyze them. And this year it will be about Microsoft Office documents. Now, you don't need Microsoft Office to be able to analyze the documents. That's why I developed my tools. So when I started with malicious PDFs, let's say in 2008, I think, the PDFs were the most popular malicious document type. Okay. And a bit later on, it was malicious Office documents. And those malicious Office documents often contained an exploit because we were still using a lot of the old file format, which is a binary file format, and which is very prone to parsing errors, which then can be exploited. Now, at that time, Microsoft published a tool. It's called Office Visualization. And with that tool, you can visualize the content of the binary document. And you can also search for binary patterns that correspond to exploits, for example, CVEs. And around the same time, a German security researcher, Frank Baldwin, released his tool to analyze Office documents. And it's called Office Malscanner. Now, from my point of view, those tools have one important limitation, and that is that they only work on Windows. Okay? So you cannot use them on another operating system than Windows. And that can be a problem because it's not always a good idea to analyze Windows malware on a Windows machine. If you analyze Windows malware on other operating system, you can make mistakes and you will not infect your machine. Another problem I had with those two tools is that when you extract the content, for example, the macros, because we will see a lot of malicious documents with VBA macros, when you extract the macros, they are written to disk. Okay? That's the only thing that the tool can do. I like also tools that, in the spirit of Unix, are piped together so that you can get the output of one tool and pipe that inside into another tool without having to write it to disk. Yeah. Now, around October of last year, a new malicious campaign started. And in that malicious campaign, they sent out malicious Office documents. They did not contain exploit, but they just contained VBA code. And that would then download a payload and extract it and execute it. And I had to analyze those documents. I didn't want to do that with Microsoft Office. You can open the document with Microsoft Office and then look at the VBA code, but you have to be careful what you do. And around that time, there's a French guy, Philippe Lagadec, who started to develop a Python module to read OLE files. OLE files or compound binary files. It's a kind of file format, a very old file format, invented by Microsoft, and that is used for all kinds of documents. I'm talking here about Office documents, but for example, the OLE file format is also used for MSI files, and the installation packages, MSI, those are actually also OLE files. Another one type I know is the quarantine files from McAfee antivirus. So the sample that is quarantined is stored inside an OLE file. So it's a very widely used file format. And he developed a library, OLE file, IO. I think it started with that a couple of years ago. And then around that time, when those malicious documents started to appear by the end of last year, he developed a tool to look inside the VBA code of an OLE file. And I did the same at the same time. I called mine OLE dump. I think we published our first release a couple of days from each other separately. We were not aware that we were working on the same thing. Now, the reason why you had to work on a tool for VBA is that VBA, the macro code, is compressed inside the OLE file. So you cannot just extract the text from the OLE file because it is compressed. Yeah? Now, the OLE file format is actually a small file system in itself. So it contains a file allocation table, it contains folders, it contains files. We call them streams. So if I'm talking about streams, I'm actually talking about files inside that file. Now we will first look if you have OLE dump running. So you can start OLE dump -h to have the help. And you should get the help. Okay. So I'm here in the in the maldoc folder of the workshop. Is that working for everybody? Yeah? If you are getting some kind of Python error, you probably install Python 3. Okay? Yeah. Yeah. So that's the next step. So if you run OLE dump without option, like this, two things can happen depending on your setup. Here, nothing is happening on my machine because now it is expecting input from the standard in. Yeah? But on your machines, you will probably get this warning that this module is missing. Okay, so you need to install this module. And I made a copy of that module on the USB stick, so you can unzip it. So in the folder install, here you have the OLE file module. So one of the ways to install it is to unzip it and run the Python setup install program to give that the command to install it. Another option, if you're using the Python that I distributed, so that's later than 279, then you can type pip space install space OLE file. And then it will get it from the internet and install it on your machine. So if you are not connected to internet, that will not work, of course. I usually do not develop tools with dependencies like that, but here I didn't want to reinvent a complete new module to do exactly the same as what Philippe developed, so I'm using his module. Okay, so can you run it now?
Yeah, let's try and see it. Minus install, is it?
Yep. No, not minus install, just install.
Okay.
You probably need to give the full path to Python.
Okay.
So it's /Python 27. It's probably not in your path. So Python 27. Yeah, /Python.exe.
Okay.
And then the command. Oh, yeah. So you need to run setup, install.
Yeah.
This is strange because I also use it then. Yeah. Let's try this. Yeah. Oh, okay, but the permission denied. You need to. Yeah. You can also have an error, of course, if you don't read, if you don't run with necessary permissions to install it. So that's also something to check. Okay, so let's try with the first exercise. Then we can see who is able to run only dump without problems. So in the folder exercise, all the exercises are in the folder exercises, and you take the first one, 001, like this. And then you get this output. Okay. Is this working for you? You get that output? Yeah? Okay. So this is a Word document, .doc, and it uses the old file format, the OLE file. And here, those 5 lines are the 5 streams, so 5 files that you can find inside that document. This here is a very simple Word document that I created. I created a Word document, an empty Word document, and I saved it using the old file format, nothing else. Yeah? These streams are streams that you will find in all of his documents. And then this one here, Word document, indicates to you that it is a Word document. And because I don't know if you are aware of that, once a Microsoft application has opened a file, it will actually look at the content to decide how to open it. I mean, you can use the new file format, docx, and call it doc with extension doc. You double click on it, and still Microsoft Office will open it for you in Word because it recognizes it as a new file format. So when you are looking at documents, this is one indication that it is a Word document. Okay? Now, these are the names of the files. Here, \x01 means that that name starts with the byte of value 1. So it's not actually readable. It's a control code. Here you have the size of that stream, so the amount of data. So Word document here contains 4K of the data, 4096 bytes. And then what I do in my tool is to number each stream. So that is not information that is inside the document, that is information that I add. And that number is there to be able to easily select the stream and operate on the stream, so that you don't have to type the full name, like one table, for example, but that you can just say 4. Okay. So the way you do that is use Option -S to select, and you select the first stream here. And then you get an ASCII dump of the content of the stream, if you provide no other options. Here also you can see that we are talking about Microsoft document. Yeah. If you just want hex, you use Option -X, like this. And then you just get X output, not ASCII dump. I use that when I want to copy that file into my 010 editor. It's a binary editor, it accepts hex code. So I just copy this to the clipboard and I paste it in my editor. That's what I use it for. Now, and if you look at the help, so we have hex dump, ASCII dump, -A, that's the default. If you don't specify what kind of dump you want, you will get by default ASCII dump. And then you can also have just a dump. So the data as is dumped to the output, to the standard output. So doing this here gives you this. The output, the stream is just outputted to standard out. And then, for example, you can pipe it into another command. So this is how you can analyze OLE files with this tool. You can see the content of the OLE file, and then you can select streams and extract the data. So that does not only work for Office documents, but for every type of OLE file, like MSI files, for example, too. Yeah. Questions till here? Now, I'm also starting with the old file format for a reason. You will become clear later on. The new file format, you maybe know already, uses a zip as a container and XML files for the streams. Right? But it's important that we start with the old file format, because that will come back in the new file format. Okay. Questions here on this one? Then we can quickly go through the other files. Exercise 2. So that is an XLS file, so a spreadsheet. And here you can see document summary information, and then workbook. Workbook tells you that it is a spreadsheet. Now, you know, Office documents also contain metadata, like the author, the date of creation, and things like that. And if you want to view the metadata, you use option -M, but uppercase M of metadata. like this. And then you get all the metadata that we can find in the file, right? Like the code page that was used, the author, when it was created and saved, and things like that. Now, the interesting thing about the metadata is that I observed that a lot of malware authors who produce files like this actually use Microsoft Office. So, and it contains metadata. So, for example, the timestamps will be correct. I often see malicious Office documents coming in. I look them up on VirusTotal. Yeah, they have been released this day. And when I look at the metadata, well, the date is the day itself or the day before. It's not like in compiled exes nowadays where the compiled timestamp can be anything. So that's a spreadsheet. PowerPoint. Oh, sorry. Didn't want to show. It's not the metadata that I wanted to show, but just the content. Like this. PowerPoint document. And then exercise 4. It's again a PowerPoint, but it's PPS. Yeah. Now, a PPT file and a PPS file are exactly the same file. So if you would do a binary compare of those two files, you will see that they are identical. The difference is that when Microsoft Office sees that you open a PPS file, the S stands for slideshow, then it will launch the slideshow automatically. While if it is PPT, it will show you the standard editor of PowerPoint. Okay? Exercise 5, docx, okay? And if you run that, there's no output. You have the same result with the exercise 5? No output at all? Okay. Let me explain you. First of all, it's a zip file. So let's do unzip test. Exercise 005. And here you see all the files contained in that zip file. Most of them are XML files, and actually those are actually also XML files. So the new file format is the XML file format with zip as a container. I have another tool. It's called zipdump. You can use that on any zip file. And like Olydump, it will also provide you with information of all the data that is found. If you use option -E, you get extra data. Come on. So zipdump -E, and then exercise 5 here. And then you get extra data. Like for example here, the MD5 hash of the file that is contained. And also a bit later, the magic number of each file, so the first bytes of the file. And you can see here that they are XML files. Now, the same thing applies for Excel and PowerPoint in the new file format, it's also a zip file that contains XML files. Now, any idea what they did with the macros in the new file format? Where did they put the macros? We will see that in one of the later exercises, but let me already tell you. They just used the old file format. So the macros are stored inside an OLE file, the old file format, and that OLE file is stored inside a zip file. That's how they did it. And that is why when you run OLE dump here on this one, that you get no output. OLE dump, when you give it a new file format, a zip file, it will search for OLE files inside that zip file. And when it finds one, it will report. But if it doesn't find anything, the output is nothing. Okay? So that's why actually I wanted to start with the old file format, because for macros, the old file format is just reused in the new file format. Okay, then we can move on to exercise 6. Like this. So you can see that exercise 6 is inside a zip file, so it's a doc file inside a zip file, and it's password protected with the password infected. It's because that from now on, it could be that some of the antivirus products will detect it and alert on it. And that's why I put it inside that zip file. Now you see that we have the same streams here for a Word document, like the summary information, the table, and the Word document. But then that we have a couple of other streams. And we have a folder macros. And this folder macros contains a file called project.wm. And then it contains another folder, VBA, which contains module 1, this document, VBA project, dir. All types of streams for macros. And something new here is this indicator, lowercase m. When you see an indicator here, m, that means that that stream contains a compressed macro. Okay. Lowercase m has also a significance. I also have uppercase, so let's see. So we have stream 7. You can select stream 7. And this is the hex ASCII dump of that stream 7. And here on the bottom you can see something like attribute. Okay. So this is actually the compressed macro code. You can decompress the macro code with option -v, v from VBA. Yeah? So if you select a stream and you use option -v, it will decompress the macro code and display to standard out. So here, the macro code is attribute VB name equals module 1. And for stream 8, we can do the same for stream 8. You get this, a lot of attributes. Now, if you work with macros in Microsoft Office, you have probably never seen this code. And that is because it is hidden. When you are in the Microsoft VBA editor, you don't see that code that is hidden. But it is included in each stream. So that is why I decided no, sorry. Here. So that is why I decided to indicate this with a lowercase m. So a lowercase letter m indicates that it contains macrocode, but that macrocode is just white space or attribute declarations. Yeah? That there is no actual code that somebody wrote. And that it is code that is generated automatically when you start. It's attribute data, but it's not actual code. While if you look at exercise 7, then here, for this one, stream 7, you have an uppercase M. So again, indicates you that it contains macrocode and that it now contains actual macrocode, something that executes. I mean, that has side effects. So you can have a look at that macrocode. So what does it do, this macrocode? Message box, yeah.
How do you differentiate between stock macros and actual code?
Sorry?
How do you differentiate between stock macros and actual code?
Like I said, if I only find let me just go back to this one. If I only find attribute space declarations or white space, then I consider it to be a stock macro. Yeah? And if it is anything else than white space and attribute declarations, then it is a macro that is interesting to look at. Okay? So exercise 7, you select stream 7 and option -V to see the macrocode, okay? And you see here that I defined a subroutine called demo and that it does a display of a message box, hello world. So this is actually how I started to analyze those malicious documents in the beginning, I mean, so in around October of last year, is just extract the microcode and see what it does. Now, number 8. Sorry. You see, it's exactly the same thing. And when you extract the macrocode, it's just again hello world. Okay, what's the difference here? You notice it? Auto open, yeah. So it's no longer called demo. Demo. Now I called it auto open. And auto open in Word macros is a reserved word. So when you call a subroutine auto open, it will do what its names imply. So this routine will start to run automatically when you open the document. unless, of course, you have settings that prevent you from executing macros or certain macros. For example, you can have a setting that says no macros need to be signed, digitally signed, before they can be opened, executed. Then it will not work. And that is what the malware authors rely on this auto-open function that starts the code automatically when the document is opened. Let's take a look then on exercise 9. You recognize the same streams, but there are a couple of extra streams. It's those 4 streams here that start with __SRP. We are in the process of reversing those streams because we want to understand what they contain exactly, because those streams are an important indication for you. When you have those streams in a document with macros, that is an indication that the macros have been executed. So up till now, all the documents with macros that we looked at were documents that I created, added the VBA code, and then saved and never executed. And this one is a previous one that I took, executed, and then saved it. Okay? So that SRP data here contains data that indicates that it is executed. We believe that it is some kind of cache to speed up the execution the next times, that it doesn't have to be completely interpreted. But that's our interpretation. We are looking into it. Because we hope that this could contain information about the process that the malware author uses to develop his code. For example, he could be testing by downloading from one of his test servers, and when that works, put in the production server, and then we hope that maybe we can find that test server here in that data. But it's something we are looking into it. Most important thing for you to remember is if you see those SRP streams, then you know that the macro was executed. Yeah. Yeah. Well, sometimes you can recognize the code. So you see here auto open and then hello world. But you recognize here this being as Unicode. Yeah? It was typed as ASCII in the code, but here it is stored as Unicode. And you can see some other file names. It's something we are looking into. But it contains information about the execution. We believe it's not meant as forensic information, but it is information, a partial compilation or something like that, a cache, to speed up later executions. Can then have a look at exercise 10. So again, this looks the same as exercise 8. A Word document with macros. You can dump the macro and have a look. So it's out to open Hello World. Okay, so I'll let you make another guess. What's the difference here between this version 10 and version 8? When you open this version 10 in Microsoft Office and you try to look at the macro code, you will be asked to enter a password. So that is the difference. In exercise 10, I password protected my VBA code.
If you can extract it
Yes?
by not using Office, then what's the point?
Yes, exactly. So the password protects it in the Office program, but it does not encode it or encrypt it in any way. Okay?
Where does it indicate about password?
Somewhere in the other streams. So exercise 10. No, I don't seem to find it back for the moment, but it's encoded in one of the other streams. But honestly, I don't care about it in a normal context. I mean, what I'm interested in is seeing the code. And what I wanted to show you is that even if the VBA code is password protected, you can just see it. Also, it doesn't require a password to execute. So it's not that when you open that document that the user will have to type a password for the code to execute. No, it will execute. The only difference that there is, if you are in the Microsoft Office VBA editor and you want to change the code, then you need a password. That's the only thing.
Is that for both the new and the old file format?
Well, think about it.
Presumably, if like macros are stored in their old
Yeah.
format. Okay.
Yeah. So indeed, in the old file, so in a new file format, we use the old file format for macros. So same thing applies. Now, another thing is if we are talking about encrypted documents. So when you password protected the document itself, then it is the content of the document that is password protected and also encrypted at that time. You can choose the provider, the encryption provider, and if I'm not mistaken, by default it's RC4, but if you have the right provider installed, you can select AES. as encryption. Yeah? And if the document, we will see that later on, if the document contains the payload, then the payload is encrypted. Yeah? And you will need the password to be able to decode that. Okay, move on to exercise 11. You see here docm. So docm is the new file format with a macro. The M stands for macros. Yeah? And if you do an unzip test, yeah, I put it. Yeah, I will need to use my zip dump tool that can handle password protected zip files too. Okay, I will need to unzip it. Okay, finally here, so I took it out of the protected zip file, and now I'm doing an unzip -t of the docm. And here you can say VBA project.bin, more or less. That is that OLE file. And the rest are XML files. Here is another one, project bin. So, and when you analyze this, no, not with zipdump, sorry, with olidump, okay, like this, you will see now that the index is not only a number of the stream, but prefixed by a letter. And that is for in the cases that it would contain more than one OLE file with macros. And then you would also have a B. So here you have the name of the file inside the zip file, that is an OLE file, and here you have the dump of that OLE file. And if there would be two OLE files, well, in normal situations you don't have that, but since it's a zip file, they can make anything they want. If you would have two files, then you would have A Word VBA project bin with the dump A, and then here B, another file name with the dump. And those would be prefixed by B. So, and then of course, if you want to select here, you have to type A3, not 3, but A3. So selecting A3 minus V, and then you dump the macro. Right? So that's why it is important to know the old file format, because the macros are still stored in the old file format. Exercise 12. Now you see an E here. That means error. So it means that I found that I detected microcode in that stream, but when I tried to decompress it, that I got an error. And that has happened a couple of times to me with samples where that compression has been corrupted, maybe with the manipulations or the transmissions that they do. I don't know the cause. But in that case here, it indicates that it contains macro, but it is corrupted. And also when you open this in Microsoft Office, you also get an error saying that it cannot read the code because it is corrupted. Yeah. Now, this is a small sample, so it doesn't work here, but sometimes, depending on the type of corruption, you can read a part of the macro. And that is why I added this option. No, not this option. Yeah, so it's something I'm still working on. So you have minus V, VBA decompress. And if you have a corrupted one, you can always try out this new option I'm working on, VBA decompress corrupt. So it's not on the it's not in the program that you have, it's in the program I'm still developing. And when you use that option, it will decompress the stream until it gets the error, of course, but then it will give you the output it already has before the error occurs. And this can also help you to analyze. But it's just if you're really, really curious to know what's going on, because when a macro is corrupted, Microsoft Office will never execute it. Okay. So now we have seen the most important file formats and how VBA code is stored inside them. The malware authors also started to use file formats that are supported by Microsoft Office, but they are really not well known. For example, you can save a Word document as a MIME document. And that can also contain macros and things like that. I have examples of these, but we will see them at the end of the workshop here. The most prevalent ones you will encounter are the old file format and the new file format, not those special kinds of formats. And before we do those, look at those special formats, we are now going to look in what kind of VBA code they use to drop Trojans on your machine. So you can have a look at the first one. It's 13, I think. Yeah. So exercise 13. Look at that microcode. So you can see it's in stream 7. So that is the microcode that I wrote. Now, when we're talking about malicious documents, there's a very important distinction between malicious PDF documents and malicious Office documents. And that is because of the programming environment. You can also program PDFs with JavaScript, but the JavaScript engine is contained. It is restricted by the PDF reader. And I'm not talking about the sandbox that has been added to Adobe Reader 10 and 11. That's another protection. What I'm talking about is that the JavaScript interpreter in Adobe Reader, for example, it cannot access your file system. It cannot read or write from your file system. It cannot access the registry. It has not the APIs to do that. While Microsoft Office VBA, that is designed to be a fully fledged programming environment. You can do anything with it if you have the skills to do it. And that is what you see here. Declare function URL download to file lib URL mon alias a and a lot of parameters. What I'm doing here is a declaration that I want to use a function of the Windows API. And the function that I want to use in the Windows API is called URL download to file. And you can find it in the DLL URL mon DLL. That is one of the tricks that is often used to download a file. So they will declare this function and then use it here. So let me clear the screen and put it on top like this. Here you also have all the parameters that are needed. And then I declare another function, shell execute, to execute a shell. In case you wonder here, you have URL download to file, and here URL download to file A, and here also ending with A. That is that the Windows API, most of the Windows API functions, those that work on strings, come in two variants. One for ASCII and one for wide byte or Unicode bytes. Okay? And internally, of course, now in the modern versions of Windows, the call to the ASCII will just transform it to Unicode and call the Unicode function. But that's what is happening here. And then in my code, auto open. Now, remark that I appended an underscore to auto open. That is just to prevent that it would run automatically when you open it, because this code is fully functional. So it will download a file from my website and my index HTML file, and it will open it. So it will be displayed in a Notepad because it is with text or your association. So that is the kind of code you will often find when Trojans are downloaded via URL download to file. So first, you have the URL. Then you have the destination, so the file where we want to write it to. Malicious documents will often write it in the temporary folder. So you take the temp environment variable, that's done with this function environment here. That gives you the temporary folder, and then I concatenate index.txt. I call URL download to file with the string URL and the string path, and then it will download the Trojan and write it to disk. Okay. So that is already an opportunity to start detecting it. The Trojan can be detected by your proxy, for example, which could have an antivirus, or it could be detected by your local antivirus when this thing is written. Unless you say we don't scan the temp folder. So we have downloaded it, and then we will just execute it. So do a shell execute, open the file that we just saved. So that is one important method that you will find in those malicious documents that use VBA. They use the Windows API to download and execute a Trojan. Okay. There's another method that's also very popular that you can find in exercise 14. So again, it's in stream 7. And this is a bit longer. So instead of using the Windows API, we are going to use ActiveX. It's another old programming environment for Microsoft. Before ActiveX, it was called COM objects, and then it got some extra interfaces, and they called it ActiveX. And there is one object in the Microsoft XML library, and that object is called XML HTTP. And that object allows you to download via HTTP. So that is the object that is very often used in malicious documents when they want to download. So first thing is the same. I have the URL, I have the path, and then I create my object. My object here, OXML HTTP, has several methods. First, the open method to build the request for the download. So this will not actually download, this will build the request for the download. So the HTTP GET request will be constructed with this method. And then with the send method, then the request is sent out to the server. And when the server receives it, the server will respond. Okay? And you wait for the response of the server by looping here on this variable. As long as this is different from 4, data is still being transmitted, so you have to wait. When that is done, you can extract the download from the body. The response body contains what was downloaded. And then here, those 4 lines, they will just write the data that was downloaded to a binary file. Yeah? Binary file, here again, string path. So that's what I do here. And then I clean up, because I tend to be a tidy programmer. That's not something you will find with the malware hunters. They will not clean up. They don't care if it doesn't work. I mean, if it doesn't work, it's a miss for them. They don't need to warn you that something went wrong. And here, I'm going to execute it. But I'm not going to use the API. I'm going to use an ActiveX object. And here you can use the shell ActiveX object, so an application, and an application allows you to execute a file. So again, this code will work. If you remove the underscore here and save it and then open it, it will download my index file and open it as a text file. So Notepad will open or your other preferred text editor. So what you see here, these two exercises, these two examples, is 99% of what's going around now as malicious documents with VBA code. That's what they do. Of course, we will see that in the exercises, in later exercises, it will not be as readable as this here. They will try to obfuscate what they are doing so that you have a harder time finding out what the URL is and finding out to where it is written. Okay. Any questions? No? So this was downloading. Something you will also encounter is that the payload is not downloaded but embedded in the document. Yeah? But that appears less frequently. It's more likely that you find something that downloads a Trojan than something that embeds a Trojan. And I believe that the difference is because of flexibility. Yeah? Once you send out the Trojan, you can no longer change it. But if you send out a downloader for a Trojan, you can still change the Trojan on the server, on your server, while the payload is being distributed. I mean, the vector. So exercise 15. Okay. What do you think this one does? So I said the payload is embedded. Huh? Yeah. So the payload is base64 encoded. Here you can see the payload. Here is a function to decode the base64 encoding, store it in a string, and then classic, write it to disk and execute it. And of course, you will need a function to do the base64 decoding, so that is also included. Yeah? So how can we analyze this? Know what's happening? Well, we have to decode the base64. Then we can have an idea of what's being done. One way to do this, for example, is to copy this string and then paste it in a binary editor that can decode base64, or use the base64. So again, select the string and use the base64 command from Linux, or use Python with the Binaski module. They can also, well, different things. But it is something that I need to do often. That is decode base64, have a look what's inside the base64. So what do? I have to do something often. I write a tool. So I have a simple tool that will search for base64 data in any data that you give it and then report that. So how this works, I have my output here from my macro. Yeah? And now I will pipe this into my base64 tool. See? Like this. And then I get all the code here. Of course, if you are providing a text, a lot of text will actually be valid base64 code. But there is one here that you can see that's a bit longer. This one here, 16, and that is hello world. I don't know if this is the latest version of base64. Let me check. Yeah. So to make it a bit more readable, I can provide a minimum number of bytes. So let me say that I want to see at least 8 bytes, like this. Okay, and then I get a lot less. So here I have my hello world. And you can also now understand that create object and shell execute is actually also valid base64. Because it's a multiple of 4 bytes, and it uses only characters that are used in the base64 encoding. Of course, once decoded, that doesn't mean anything. Okay. I will let you start and to do the next exercise. It's also with the embedded payload in base64, but it's a bit different there. So if you can tell me what the difference is there in that next exercise. Oh, I still have chocolates. So the first one who tells me gets a chocolate. In the document. Yep. Here you go. So if we look at the macrocode in stream 7, sorry, that's cap lock. So here you see our decode 64 function, but instead of base64 string, we see active document content text. So this is an object with properties that allows you to extract the text from the Word document. So the actual text that was written inside the Word document, you can access this through this object and methods. Properties.
The entire body?
Sorry?
Is that the entire body of the document?
Yeah. So in my case, here I kept it simple. You see? This is the Word document, and it just contains this base64 string. Now, in reality, when this is used, you will often find a text that is designed to social engineer the user into believing that it is a real document. And later on, appended to it, you will have the base64 code. Yeah? And they will precede the base64 code, precede and prepend the base64 code with a special sequence of characters that they will look up. So, for example, let's call this payload. So you have all your text, then payload, and then the base64, and then again payload. And then in the macro code, here, they take the text they do a find for payload, and then they have the start of the payload of the base64. They do another find, they have the end. They extract the base64. It's just a bit of string manipulation, and then they are able to decode it. Okay. Now, if the Word document is encrypted, then in this case, you cannot retrieve the payload without knowing the password or trying to crack the password. But usually when malicious documents have a password on the content, then the password is also communicated to the user. But of course, it's not always the case that when you as an analyst receive a malicious document, that you also receive the original email with the password included. But again, when that is used, a password has to be provided, and if the password is not correct, or if the user does not type in the password, the payload will not execute. Okay. So now we have seen the two major ways where a Trojan is delivered through malicious VBA code, that is with a downloader, or with the Trojan embedded. Now this was all code that is readable, but for now we will have a couple of exercises with obfuscated code that I will give you a small insight of how malware authors will obfuscate the VBA code to make it less readable to you. And also not only you, but also to mislead, for example, antivirus engines. Because there are many antivirus engines that can extract and decompress the VBA code and scan through that. There is, for example, there's an antivirus, for example, that will trigger on some of the API calls, so declare function with that name. Will trigger on that. But because those are strings, you can also do string obfuscation on them, and then you can bypass that detection. Okay. So let's start with these obfuscation methods. I think they will always be in stream 7. Yeah. So exercise 17, stream 7. That is one of the very first obfuscation methods that was added. I mean, in that campaign that started in October of last year. When you see this at the beginning of the line in a VBA code, what's the meaning of that? It's a comment. So all these here are comments with just some random text that I typed on the keyboard. Right? So this is comment, and comment is just ignored by compilers and interpreters. Comment is ignored. But by just adding comment, they make it already less readable to you. Another thing that I did here is also that I put everything on the left side, not with proper indentation like a programmer would do, but everything to the left, so that you have a harder time of seeing constructs like ifs and loops and things like that. Okay, but if you take a close look here, you can still see URL. Yeah. Now, when they started to make the obfuscation more and more annoying, I changed OLEDump so that it would support plugins, so that you could add your own code without having to modify OLEDump. And one of the plugins that I started to code is a plugin that tries to recognize URLs that are in the VBA code. And you use plugins like this. So you have OLEDump. You say -p that you want to use a plugin. And the plugin we are going to use here is plugin HTTP heuristics. This is a plugin that I coded, and sometimes I make updates to it, that implements the detection of all kinds of simple string obfuscation techniques used by malware authors. And then you can give it exercise file. '17, like this. And when you use a plugin, you don't have to select a stream. The plugin will run on all the streams. This is a plugin designed for macro streams, so it runs twice here on those two macro streams. If the plugin finds an HTTP URL, it will dump it. If it doesn't, it will dump a string which it has manipulated like malware authors would, and sometimes in that string you will recognize a partial URL, and this could help you. Okay? So here you only see URL, nothing else. So I have plugins that work on streams, and I have plugins that work on macro streams. This one here is a macro stream. I have different plugins. I also have a plugin for different obfuscation techniques that were used by the Dridex team. And then you have to use that plugin, the plugin Dridex. You can combine plugins, so you can specify more than one plugin just by separating them with a comma. So here, comma plugin Dridex, no spaces, just run on. Okay. And then you see the plugin HTTP and the plugin Dridex decoder, both plugins running on each stream. The Dridex decoder will only output something when it finds an HTTP URL. Okay. Now take a look at exercise 18. Okay. In the VBA code that I gave you before, I used meaningful variable names and function names. This is here no longer the case. It's just, again, random names. Most of the time, you will find it like that. Here, instead of string URL, you see this one here. Objects with HTML, XML, HTML, well, it no longer has that name, but it has become that. But again, here, the URL is still in clear text, so it's easy to find if you do a find on the HTTP. Next one, 19. That's another trick that is used in real malware. Here, when you start looking at the code, so you have declarations here, and here you have actual code starting. So I have a variable assigned a value of 64, another one 69, and then the sum of those two variables, so that's 133, checked if this is bigger than 2, yes, it's bigger than 2, then we say that this variable equals this variable plus 9. If it is not bigger, we do an input box of 63, and we end. And if you look for those variables here, they will be again used for the same code. This is actually useless code. This code doesn't contribute anything to the downloading of the Trojan. It is just there again to make your work more difficult, that you have to weed out all of that code to find things. This is actual code that I took from a sample, this part here, so you can really see how they do it. What I've also seen a couple of times, but not that frequently, is that they will just take source code from VBA forums or other open source projects and put that in. For example, I had code that would access a SQL database and extract rows from a SQL database, and those functions were in there, but they were never called or not used at all. That is, again, to make your work more difficult, and maybe also a bit to social engineer you, to maybe try to believe you that it's actually useful VBA code and not malicious VBA code. But here, still, the URL here in clear text, so that's easy to find. Okay, I think the next one is 20, yeah, so take a look at 20. This one is a bit different. So here now we see an obfuscated string. It's base 64 encoded. And you have a decode 64 function. But if you look here in the code, you don't find the definition of that decode 64 function. You have to look in the other stream, stream 8. And there you can see it as a public function. So that is something they often do, is split the code over different modules. And as long as the functions and the subs are public, they can be used from other modules. So, but it means in your analysis that you have to look at different modules. Now for that, there is a small trick. So here we selected 7 and we selected 8 to view. You can also do A, select A, and the A stands for all. And then it will select all streams and dump the VBA code of all streams. So, and then you have it in one output. Okay. So this is, up till now, what I showed you was code obfuscation. We obfuscate the code by adding comment, by adding useless code, well, code that does something, but it's actually not producing results, by using random variable names and function names, by splitting over several modules. But the other thing that is done a lot is also to obfuscate the strings. One of the things, for example, is base 64. So now we will look into some of the examples. So here we have exercise 21. So you see base 64 here. But if I decode that with base 64, and so here I have the base 64, LMHTM, so it's actually written in reverse. It's a very simple trick, but often used, that they just reverse the string. Yeah. Let me put it on the top. Here. So when you decode this base 64 string, you actually get the URL in reverse. And you can see this in the code. So we have decode 64, but here we have string reverse. String reverse is a built-in function in VBA that reverses a string. My HTTP plugin also has a heuristics for that. So if you use that plugin, here, it can extract the URL. So that's reverse. I think you can come up with your own tricks to obfuscate URLs. For example, exercise 22. Okay. So what do you think exercise 22 is?
Encoded.
Yeah. Here the URL is encoded. Again, you can use the plugin to make life more easier. And the plugin knows that hex encoding is also used and decodes it. Okay, another one, another ID. Ever heard of ROT13? Well, they use that too. So exercise 23. If you ever see somewhere UGGC, know that it is HTTP in ROT13. I can read a bit of ROT13 for two reasons. I also developed a tool called User Assist, a forensic tool, that retrieves the user assist information from the Windows registry. The user assist information is what is used to, in your start menu, show you the programs that you use often. So every time you use a program via the Explorer interface, that is added to an entry in the user assist registry keys. Okay? And Microsoft had a brilliant idea to obfuscate those names of those programs with ROT13. That's one of the reasons why I can read it a bit. And the other reason is geocaching. I play geocaching, and sometimes that is also used in hints. Of course, I had to use ROT13 support in my plugin. There you have it. Okay, another ID. What more can you do? Starting to use bit by bit, starting to use encryption. Instead of just doing simple encoding, starting to use some kind of simple encryption. And one of the things they do is XOR. So your URL string, for example, here I represent it as hex. This URL string is actually encoded with XOR, and the key is secret. But this is also something I coded. I did it bit by bit when I saw these kinds of obfuscations appear. I added those obfuscation decoding functions to my HTTP heuristic plugin. And again, of course, you can see that it can decode it. This is also the advantage of working with a plugin. So I don't have to add all that code to OLEDump. From that point of view, OLEDump remains stable. And I just have to do it in the plugins. And the other thing is also that I can code my own plugins that I don't want to distribute. I have, for example, one plugin. We will see it later. It's something I have not yet distributed. I don't know if I will. But anyway, it is included on the USB stick. So it's distributed in this small group. And I think I've stopped with XOR encoding. Let me check. Yeah. But that's not where the criminals stop. I will not give you an example of everything they do. One of the things, of course, they do is combine things like that, like I did here, base 64 and reverse, or here hex and XOR encoding, things like that. They have also implemented a kind of RC4 cipher that they used to decode and encode. If I'm not mistaken, I added that to the Drydex decoder. But then another obfuscation method you will often see is the following. That's in exercise 25. You can have a look. Yeah, you see, per mistake, I run it with a plugin, and the plugin just found HTTP, nothing more. Yeah? So there is something there, but it hasn't been able to get the full URL. So in stream 7, so there is a group that produces malicious documents and that always uses that kind of obfuscation. They will split the string, the URL, in different strings and then concatenate them back together. Yeah? But my HTTP heuristics plugin is very simple. It just looks at individual lines. It doesn't look at several lines together. But I started to code another one, and that is the VBA plugin. This is kind of a silly project to start. It's actually a small parser for VBA. It doesn't completely parse VBA, but it recognizes structures like variable assignment and method and function calling. And when it recognizes these, it will try to understand the expressions. And when it does, it will also build up the variables. So in this case here, my HTTPA plugin is able to recognize these variables, that they have these values, and then concatenate them together. So we can try that out. So the plugin VBA. Yeah. And this plugin will report each variable in which it finds HTTP as a string. Of course, what I showed you here is simple. Again, what they will do is obfuscate parts of those strings with other methods. So it becomes harder and harder. I also saw that they started to not write, that they would not write in their string HTTP, but that they would write, for example, HTT minus TP. And later on in the code, they remove the dash so that it ends up as HTTP. So what I did in my plugin is when I look for HTTP, I just look at the letters. I ignore everything that is not a letter. And if I find HTTP, then I report it. It's an arms race. Huh? This can go on forever. But the big advantage of doing the analysis of malicious documents like this, as opposed to doing a dynamic analysis where you put it in a sandbox or in devices like from FireEye, things like that. Those devices will report what the machine did. So you will see, for example, the download of HTTP and then other HTTP things like that. But those other HTTP accesses come from a Trojan that was downloaded. And I've seen several of those analyses of malware that I know and submitted, and it's never clearly indicated what part is the first stage from the VBA and what part is from the second stage, the Trojan that was downloaded. Because if you are in an environment, and those corporate environments tend to appear more and more, if you are in an environment where you no longer have internet access, then if you know that an HTTP request would be made by the document to download something, well, for you then the analysis is done. Because you know that in your environment, nothing else can happen because there is no internet. But if you find an embedded document, well, that is the difference. Then you need to continue because internet doesn't come into the equation. So this is just a small overview of all the simple obfuscation techniques that are used, obfuscation for code and obfuscation for strings. And it is designed to avoid detection by antivirus and IDS and things like that, and also to make your life harder when you need to do it manually. You can try the plugins that I have, but if that doesn't work, then you will have to do it by hand. Okay. The questions here? No? No? Yeah?
So you mentioned at the beginning of the talk about how you could read input from standard in. Have you done anything with reading input from, is that just expecting a normal Office document, or have you done any other types of file like packet captures or file fragments?
No.
So it has to be a complete.
Yeah.
Properly.
Yeah, but you can use several of those tools that will, I forget the name now, but there are several command line tools that extract all the files that you find in a packet capture. And then you can pass it on, because that's not something I mentioned, but OLEDump will return an exit code 1 when it detects macros, and 0 if it doesn't. So that's the first filter that you can use. Now, before I move on to the special file types, we have 10 minutes left. This here, what we did is looking at malicious documents that don't use any exploits. Some of them, of course, use exploits. But starting with the new file format, that becomes more rare. But I have added Jara support to OLEDump, and I have worked on Jara rules to try to decode, try to detect shellcode and other artifacts of executable code. So if I go back to my presentation here, Office Mal Scanner So Office Master Scanner is able to extract all the macros and write them to disk, and then you execute, you analyze them. But it can also scan the Word, the streams in the documents for artifacts of executable code. Like, for example, shellcode that tries to find its location in memory, or shellcode that tries to look up the addresses of API calls and things like that. So Frank Baldwin coded a lot of rules to detect those assembly constructs. He has a paper on that. I was in touch with him, and he gave me his permission to translate that code that detects assembly instruction often used in shellcode, and that code to transform that in Java rules. Okay? And those Java rules can be found here in the folder. They are called Maldoc Java. So here I have one for API hashing, so trying to look up API functions, function prolog signatures, structured exception handling, all kinds of rules that I created. I have another Java rule here. And this is a Java rule that detects if a PE file can be found inside a sequence of bytes. So a PE file, a portable executable file. So what I actually do, I look for the 2 magic bytes that start a PE file, MZ. But I go further. When I find an MZ, I will look a bit further with this instruction here to see the offset that points to the PE header. Because if you know a bit of the PE file structure, it's the old executable structure plus the new PE structure. So I look for a MZ, and then at a certain position in code defined by the values found in the byte stream, I look if I see PE. Okay? And that is the rule to detect embedded PE files. Now, I think it's exercise 26. Let me check. Yeah. So, ole dump minus y here for Java. And you will probably get an error, but let me explain. So, contains PE file, and here exercise 26, like this. So you will, when you run this, you probably get an error that Java module is not installed. So to be able to use Java with ole dump, you need to install the Java module. Now I designed ole dump that it will only complain about the missing Java module if you effectively use Java rules. Up till now, we have not used Java rules, so it has not complained about missing Java module. So you only need to install it if you really want Java. If you are on Windows, I've included the Java MSI, so you can install that. If you are on OS X, the best thing to do is do that with Homebrew. So you do brew install Java. And for Linux, you will have to look on the Jara page. There are several modules for Linux, and watch out, take the Jara module for Python from Victor, so the developer of Jara, because there are also a couple of Python interfaces for Jara, but those do not work with my code. I used his definitions, not somebody else. Okay. Now, it's not that important if it, for this exercise here, if you can get it to run or not, but I can simply explain it. So I'm saying that I want to use a Jara rule. Of course, I can specify more than one Jara rules, like I can specify more than one plugins. And then it will apply the Jara rule on each stream. And if it finds a hit, you will have here an entry Jara rule contains PE file. So here, in this stream, it has detected a PE file. If you want to know where, you add option Jara strings. And that will print out the strings found by Jara. So at position 66 hex, it found MZ. Yeah. So I forgot the stream, so stream 7, yeah. So if I select stream 7 now, and do a ASCII hex dump, yeah. Here I can see the start of the PE file. And here this DOS stub, this program must be run. And a bit further you will see the PE header. Yeah, here you have the PE header. And then the different sections are like data, our data, TLS, text. If you want to extract this, no, let me first show it again. So this here was embedded as an OLE object inside the file. So in Office documents, you can embed all kinds of files and objects. I just did that. And when you do that, not only is the object embedded, but also the folders and file names from where it comes. To extract this PE file, you have a function, a method, that you can call with option, and this option is extract. Okay. So I select object 7 here, and I do an extract. And then it is extracted to screen. I have a tool to analyze PE files on my machine here, users. It's called PE check. And here you can see all the information of the PE file. So first of all, because it is able to analyze it, it's a valid PE file with all kinds of information. And at the end, it will also use the PE ID database to identify it, that, for example, this one here was compiled with Borland. Yeah. Now, just one thing I want to mention, not going to demo it. So here the PE file was just embedded like it is. But often it will also be encoded in a simple way, like a simple XOR or a ROT or a roll or things like that. For that, I also have decoders. And those decoders, they work like plugins. So if you look in the folder, you have several decoders. A decoder that adds 1, a decoder for CHR, for roll 1, for XOR 1. So in this way you can, for example, do a brute force of XOR, but on just a key of 1 byte. Yeah. That was also one of the functionalities that Office Small Scanner had. And then we have the last one here, 27. And if we run the Jara maldoc rules on it, it will tell us that it found a sequence for get EIP. So that is one of the methods that shellcode uses to locate its position in memory. That's one of the first things it has to do, 32-bit shellcode. So it found one here in this one with Jara strings. You can see the value. So this is the value E8000005B at location 56. So let's select this. And 56, yeah. Here you have the start. And here at the end you can see hello from injected shellcode. That is a shellcode that I wrote and that just displays a message box. So if you would extract this byte stream and disassemble it, you would recognize shellcode. Of course, again, if this is simply obfuscated with an XOR encoding, for example, you can use the decoder. Another method to analyze malicious documents that don't use VBA, but that use one kind of or other kind of exploit, is to parse the complete structure. And I have done this for Excel. Let me check. Yeah, so I have this plugin here, plugin BIF. So BIFF is the file format that was used for Excel even before it belonged to Microsoft. So a very long time ago. And you can guess what happened when they upgraded to the OLE file format. They just put the BIFF format as a stream in an OLE file. And I have a simple plugin to decode that file format. So let me show you. Only done. BIFF. So an exercise 002, that's an XLS file. Okay. And then in Wordbook, you get all the BIFF records. For example, password, protection flag, the code page, all kind of information. And if you really want to go hunting for potential shellcode or ROP code, which is even more harder to detect, you would parse this structure and see if you find unexpected values in there, which is hard to do, of course. But there is a method to do this, but it's extremely difficult. I once did it on a spreadsheet we received. We had to be absolutely sure, but luckily for me, it was a very small spreadsheet. And I could be sure by looking at everything that there was no malicious code in there. And also, if that plugin would crash when parsing, that also indicates that there is something wrong, because it doesn't respect the file format. And then we are 6 minutes over time, but let me just mention you that there are a couple of other file types that are also used. So you can, for example, save a document, a Word document, as mHTML. And that is actually a MIME type file. So like an email that is sent, a MIME type file. And I happen to have, for other reasons, a tool to dump MIME files. It's called EML dump. All my tools are called dump, as you can see. Exercise 34. Sorry. Okay. So, and with this one here, you can see all the entries in the MIME type file. Now, the M here, that's not an indication of macro, because there is no context of macro. M here just says that this is a multi-part MIME. If you have such a MIME file, you have to look at an MSO file, because the macro of the macro part of the Office document saved as a MIME type will be in an MSO file. So OLEDump cannot parse those MIME type files directly. So it was 34. You see, you get an error. That is because I already had my EML dump tool, and I just want to use that. So I select stream 5, I dump it, and then I pass it on to OLEDump. Like this, and here you can see now the macro code. Select 3v, and here message box hello world. So that's one of the types, MSO files. OLEDump can read MSO files and then extract the OLE file, because the MSO file will contain an OLE file, and extract it. But MSO files, they themselves can also be stored in another file format, like EML, also XML or HTML. So for those file formats, you need to extract the MSO file and pass it on to OLEDump. And then a last one, it's a new tool I'm working on, because that full file format is again starting to appear in malicious campaigns. That is an RTF file, a rich text file. A rich text file has a completely different format. In fact, it's a bunch of grouped accolades with control codes that start with a slash and a name. So, for example, accolade/RTF, that indicates the beginning of an RTF. And then it will contain the text and the code and makeup and things like that. Now, RTF files cannot contain microcode. So that's already a good thing. We don't need to look for that in RTF, and it will not execute. But when you have malicious RTF files, two things can happen. One thing is that a malicious file was included, embedded, and that the user double-clicks the icon in the Word document and then the code executes. That's one thing. And another one is that they use real exploits, because there are still exploits being found in several ActiveX and COM objects that you found on normal installations of Windows with Microsoft Office. And then they try to exploit them via RTF, because you can embed any ActiveX object in RTF. The tool I'm working on, but I just started to work on that tool a couple of days ago. Okay, what's its name? RTF dump. RTF dump. Exercise. Like this. And you will get this output. So in an RTF file, you have nested groups, and that's the nesting that you can find. The position, the length. Here, and we'll always start with RTF1. And then the things we are interested in are embedded objects. Let me show you. Yeah, here. Object class, object data. Those are embedded objects. And when those objects are embedded, they are embedded with hex code. Okay. The H here indicates that this group here contains hex code and that you can extract it. And when we would extract this one here, we would find an embedded executable. Okay. Now, the analysis, I expect that the analysis of RTF files will be much harder to code, because RTF files, malicious RTF files, are produced with special malicious tools, like the malware Word, it's called MWI, malicious Word something. It was in the news a couple of weeks ago. And this malware tool does not use Microsoft Office's components at all, because it's just simple to produce that file format. A simple RTF file that displays hello is just a couple of lines that you can type yourself. Yeah? But because this is a file format that they can manipulate, I expect that in the future they will also start to do obfuscation in the file format itself. For example, if you have a bunch of hex strings, that they will also somewhere inside the hex strings start to add empty groups. Yeah? And those empty groups will have to be ignored, because they are ignored by most readers like Word. Okay? But just remember, for RTF, so I'm working on a tool for it. It appears now since a couple of months as malicious documents, send it out. Of course, they often don't call it .rtf, but they often call it .doc or .docx. But like I told you, any file that Office can read, it will read. It will transform it and read. And in RTF files, luckily for us, no macros. I tried it even creating a spreadsheet with macros in it in the old file format, embedded it in an RTF file, saved the RTF file, and when I did my analysis, my macros were gone. So Excel streams were still there, but the macros were removed. RTF is used for two major cases: embedding malicious files and then social engineering the user to open that embedded file, or else exploit inactive objects that they find in there. Yeah. So I'm a bit over time, sorry. 50 minutes. Any more questions before I finish the workshop? No? Okay. Thank you.